A very useful way to think of data, especially when you're dealing with whether it's quantitative or qualitative data, is to classify data in terms of levels of measurement. And to do that, we would classify data in one of four groups, whether it's nominal, ordinal, interval, or ratio. When you're dealing with a qualitative variable or qualitative data, you'd classify that as either nominal or ordinal. And when you're dealing with a quantitative variable or quantitative data, which can be discrete or continuous, you will classify that as interval or ratio. So next up, we'll discuss what each of these mean. Now, a nominal level of measurement deals with categories only. So when you are working at a nominal level, you'll be dealing with a categorical variable or categorical data. And the way I remember this is nominal rhymes a bit with name. So what we are doing here is basically naming. This is characterized by data that consists of names, labels, or categories only. Right? Names, labels, and categories. Right? So you are basically naming groups. And the data cannot be arranged in an ordering scheme, such as from low to high. Right? So you are basically just naming things. And the order of those groups is not meaningful or has no meaning, and it's not important. An example would be, let's say, survey responses that can be yes or no. Right? These are two groups, the order of which is not important. Right? And others can be, if you are talking about race, the other would be blood groups. Another example would be, let's say, marital status. Right? So the order of these groups does not matter. So it's just basically naming, hence nominal. Now, ordinal deals with categories with some order. Right? So unlike nominal, here there is some order to those categories. But note that we are still dealing with categorical variables or categorical data. The way I remember ordinal is that there is an order to it. Ordinal rhymes with order, right? There's an order or a rank to it. So this involves data that can be arranged in some order. But the important thing is the differences between data values either cannot be determined or the differences are meaningless, right? Examples, let's say we are grading students in, let's say, statistics, right? Grade A, B, C. There is an order to this grading system, right? But you can't really determine the differences between A and B and between B and C or between A and C. Although the groups themselves have an order to them, the differences between them are not really meaningful. Another example, good example, is when we are grading, let's say, murmurs, right? Heart murmurs or cardiac murmurs. We would grade them as, so these are cardiac murmur. We would grade them as low, medium, and maybe high, right? The order is important, right? Because we know that, okay, low grade is of it's less severe compared to high grade, but we cannot determine any differences between the groups themselves. Another example is cancer staging. So cancer or stages of cancer, so you can have stage 1, stage 2, stage 3, stage 4, right? The order is important, but the differences between the groups either cannot be determined or the differences are meaningless. So I'm sure you can appreciate now the difference between nominal data and ordinal data. Now, when you're dealing with quantitative or numerical variables or data, that can be, remember, they can be discrete or continuous. You'll be dealing with an interval or a ratio level of measurement. So for interval, we are dealing with data that can be arranged in order, right? So it can be arranged in order, and the difference between any two values is meaningful, right? However, the key differentiator between interval and ratio is that for interval, there is no natural zero. So we don't have a natural zero starting point where none of the quantity that we are measuring is present. An example of this is time, right? Good example would be time. We can't have, or time, especially in years, does not have any natural starting point, right? Another good example is temperature in degrees Celsius. When you're measuring temperature in degree Celsius, so we are using the Celsius scale, right? We do not have a real or zero starting point, because with this scale, 0 degree Celsius does not mean the absence of heat. This 0 here is not a natural zero starting point where none of the quantity is present, right? So that's the interval level of measurement. The next one is ratio. So in essence, it's like the interval level, but with the additional property that there is also a natural zero starting point, where 0 indicates that none of the quantity that we are measuring or none of the quantity that we are talking about is present. Differences and ratios are meaningful in this case. So an example is, let's say money. When we are talking about money, can be in dollars, right? $0 means no money, right? Someone with $2 has $3 less than someone with $5, right? And an individual with, let's say, $10 has twice, right? Has twice, 2 times one with $5. Okay, the next example is, let's say you are counting people, right? 0 means no people. 1 means you have 1. 2 means that you have 2 times 1. 2 versus 10 people means that you have 5 times 2, right? So you can see that the ratios and the differences become meaningful. Another example is weight, right? You can have 0 kilograms. Another is height, where you can have 0 meters, right? There is a natural 0 starting point, where 0 means that none of the quantity we are measuring is present, right? So that's the key difference between the interval and the ratio levels of measurement.